Hello everyone, so myself Satya from SNS College of Technology. In today's class we are going to solve one problem, so which is from large sample. So first we should check n value, whether it is less than 30 or greater than or equal to 30. If it is less than 30, which is under small sample. If it is greater than or equal to 30, which is large sample. Okay, so first I want to check, now I am going to read the problem. Okay, a sample of 900 members is found to have a mean of 3.4 centimeter and standard deviation 2.61 centimeter. Is the sample from a large population of mean 3.25 centimeter and standard deviation 2.61 centimeter. If the population is normal, we need to find 95% of the confidence. This is the thing we need to find. Okay, so the first thing is I want to check n value. Okay, so n value is what? N is equal to 900, so which is greater than or equal to 30. That means we can say which is large sample. Okay. So under large sample we will have 4 types. So there are 4 types. The first type is single mean, then difference of means, single proportion, difference of proportions. Okay. So this question is based on mainly mean, which means either it should be single mean or difference of means. Here we are having only one set of samples. That means we can say that is single mean. Okay. So for single mean, you can see the first statement, a sample of 900 number and its mean and standard deviation which is given. You can take mean as x bar, so that is equal to 3.4 centimeter, and standard deviation is s is equal to s r sigma. Both notations we can use because both are equal. That's why we are taking s r sigma. Okay. And the next thing is they are given. In the next statement, they are given mean as 3.25. That means that is the mu value. So mu equal to 3.25. So first thing I want to write the data from the given problem. Okay. Now we are going to move into these steps. Okay. There are 5 steps. One by one we are going to see. Okay. So first thing is step number 1. That means we need to make the hypothesis. Okay. The notation is what? H naught. Okay, so I want to take the population mean, which is nothing but mu. So mu value is what? The value is 3.25, and I want to write h1, which is nothing but alternative to this h0. Okay, that means I want to check in the given problem whether I have any conditions, but here we don't have any condition. That means we can say which is 2-tail test. Okay, so we can take for 2-tail, I want to make mu is not equal to 3.25, and I want to mention which is 2-tail test. Okay, the next thing is we need to write alpha. So alpha is nothing but level of significance. We can check the confidence limit, which is 95%. That means the alpha is 5%. Okay, so you can take the value as 5%. And step number 3 is how to make use of the formula. So which is z equal to, formula is x bar minus mu by s by root n. So using this formula, we need to find the answer. Okay, this is calculated. Right? So x bar is what? X bar equal to 3.4 and mu is 3.25 whole divided by s value is 2.61 by square root of, take n value, n is nothing but 900. Okay, now I want to use the calculation. So using the calculator, now we are going to find the answer. Okay, so the answer is what? Yes, the answer is 1.724. Okay, using the calculator, I want to find this answer. Okay, shall we move to the next step? Yes. Step number 4 is, okay. Step number 4 is what? We need to write the table value. So here 5% and 2-tail test. The table value is z alpha equal to 1.96. That is hard to remember. Okay. Next thing we are going to compare the calculated value and table value. So that is step number 5, which is nothing but the conclusion part. Okay, so the conclusion is you can take modulus of z, which is 1.724, and modulus of z alpha, which is 1.96. Okay, now you can check which is the maximum. Here table value is the maximum. That means we need to accept the hypothesis. So from this we will have the assumption as the population mean is, because h0 is accepted, h0 is what? Mu equal to 3.25. That means the population mean is accepted. Okay. The second question is we need to find the confidence limit. For that we will have the formula. So the formula is, so this is the formula, mu equal to x bar plus or minus z alpha, then then sigma by square root of n. So this is the formula. Just replace all the data in this formula. So x bar is what? X bar is 3.4 and z alpha is nothing but the table value, which is 1.96, and sigma is the standard deviation, which is 2.61 by square root of n value is 900. So finally we are going to get the answer as 3.23 and 3.57. Okay, this is the two values we are getting from mu. Okay, already we are having mu as 3.25, that is how to verify whether 3.25 which lies in this interval. If it lies in this interval means the part is over, right? That is the thing we need to verify. Okay, thank you.